Good afternoon, everyone, and welcome to this AHDB potato storage webinar titled "So Far So Good Without CIPC?" So I'm Alex Wade, Knowledge Exchange Manager for the West Midlands, South Western Wales, and I'll be chairing today. Our speakers today are Adrian Cunnington, Head of Crop Storage Research at Sutton Bridge, Glyn Harper, the Crop Storage Senior Scientist at Sutton Bridge, and Simon Alexander, an agronomist from SA Consulting. So before we get started on the programme, I'll just run through some of the usual housekeeping. You're all on mute and cameras are off, but you are able to send questions in using the question box that should be on the right of this webinar screen. The webinar is due to finish at 4:45, but if we have some good conversation and questions during the Q&A, it could run over a little bit, and you're welcome to stay and listen to that. Basis and ROSO points are available, so if you put your details in during the registration process, then that will automatically get sorted for you. And if you didn't, don't worry, just drop your name, postcode, and your basis and ROSO number in the questions box on the right, and no other viewers will be able to see your details. We'll get that sorted for you. And the final point is that this webinar will be recorded, so if you want to listen back, it will be on the AHDB Potatoes YouTube page in the coming days, and you'll also receive an email link for the recording. So the programme is my bit, this welcome and introduction at 3:30, and then in a minute we'll have Glyn Harper on a update from sprout suppression trials at Sutton Bridge for 20 minutes. And then following on from that, weight loss and compression in long-term storage from Adrian Cunnington. And then that will last 20 minutes and we'll go into storage 2020/2021, what we wish we'd known a year ago from Simon Alexander, who's an agronomist. And then depending on the times they finish, about 4:30, 4:35, we'll look at questions and a discussion with a 4:45 close. So first off, before we get the speakers in, I'd like to ask you all a question, and it's going to be as a poll. But before we get the poll up, I just thought I'd ask the audience to think about a couple of things before answering and going to default answer. It may not change your decision, but we'll see. So following the withdrawal of CIPC back in January 2020 and use up October 2020, how do you as an industry agree with the statement, so far so good without CIPC? Now, CIPC has been around for 50 odd years, I believe, and there were many benefits, including cost, efficacy, etc. But I'd like you to think about how you imagined it would go, having heard back in January last year, versus actually how it's going at the moment. And if you're a grower who's used CIPC and has had to switch to an alternative, despite potentially the cost, are you happy with the results, or were you surprised at how far maleic hydrazide and or natural dormancy actually took your crop with good store management? Now, Christian, if you could put up that poll, and now having thought about those few things, the question is, so far so good without CIPC? And if you select the one of those following statements that you think is most appropriate. So we have strongly agree, agree more than disagree, disagree more than agree, or strongly disagree. We'll discuss this at the end with the speakers, but I thought it'd be a good starting point to get everyone thinking. And I'll be quiet now and let you have a think about it for 20 seconds or so.
Yeah, we've had over half people voting, so I'll give it another 5 seconds or so, and then I'll close it.
Good stuff. Right, so without further ado, I shall pass on to the first speaker, Glyn Harper, to discuss the updated trial results from Sutton Bridge.
Thanks very much for that, Alex. Next slide. Thank you. So this slide shows a hierarchy of controls that together lead to efficient and cost-effective storage. You can see there's various elements of it. But the key thing is that sprout suppressants, although they're at the top of that pile, they're not the most important. They're all required together. At the bottom, we've got variety. Really, I think that's wider than that, that particular layer. I think it must also include the quality of potatoes coming into store following harvest. AHDB has commissioned a number of projects to provide information about these controls and their improvement in the absence of CIPC. And I'm going to go through a few of those now. I'd just like to start off with a comment about management, though. So that's store setup and operation, obviously absolutely fundamental to good storage. So there are various publications available, but also advice through Sutton Bridge, through the Storage Advice Line, and through store visits through the Storage Network Initiative. And if you want any more information about that, then please contact Sutton Bridge. Okay, next slide, please. So what this slide shows is that in the title, there's S1060, and that's an internal Sutton Bridge number for the trial. And it's called ethylene and low temperature tolerance. If you want any more details about these particular projects, because I'll be going through them at a fair rate, they're all available on the AHDB website. And I think if you search with wildcard 1060, you'll come up with this report for this particular trial. But this is really to show that we're looking at the low temperature tolerance of some processing varieties. So how well will tubers process if they've been stored at either 6 or at 8 degrees C, and there's some interesting results from that. And also how well do different varieties respond to ethylene. So there's ethylene is particularly has a strong varietal component to it, and we're looking at different crisping varieties, or in fact and chipping varieties, for their ethylene responsiveness. So here's a panel of 8 crisping varieties, or varieties that have been crisped anyway, and you can see there's some very nice fry colours there. So ethylene is by no means verboten for the crisping industry, at least for those varieties. Okay, next slide, please. This is another trial, so 1058, and it's to do with relative dormancy of varieties. So this would actually sit in the lower layer of that hierarchy. Clearly, if you've got longer dormant varieties, they're going to be easier to store and less problematic to maintain the quality, especially in terms of sprouting. So this is an ongoing trial where varieties have been, this number of varieties have been planted in the same location in spot farms usually, or in this case, Mark Means' field. He generously volunteered it. We planted these varieties and at harvest taken them back to Sutton Bridge, where we'd assist on a weekly basis for sprouting, and we've come up with this histogram. You can see it's a continuum going from on the left, King Edward, which is known to be a very early low dormant variety, through to Taurus and Marquise, which would be typically long dormant. It also includes Desiree, which for the second year in succession has appeared as a very long dormant variety, and we're trying to understand why. But within that, if there's any potential to do so, selecting varieties from the right-hand side of the list of the graph would be preferable to those on the left-hand side. Next slide, please. So now this is the major part of the talk, is going to be 2 projects on where we're looking at sprout suppression of pre-pack and of processing varieties, and we're comparing the relative efficacy of a range of approved or near market sprout suppressant treatments, singly and alone. The key part of this singly and alone bit is maleic hydroside, and we had some local growers who are very generous with their crop and allowed us to cover a portion of a crop immediately prior to MH application, and we then uncovered following MH application. You can see in the distance another plastic sheet, so each field had got four replicate plots. So we could harvest what had been the covered area and an area immediately adjacent to it. So we've got essentially identical crops, with a single difference of the MH residue, MH content. Next slide, please. This does remind me, it's another spot farm trial. So this is some work that's been run by Adrian, and he's been looking at the effect of MH residue in a tuber and the consequences for sprouting. So we can see on the x-axis at the bottom, that's the average residue concentration going from not very much to about 15. And on the y-axis, the weight of sprouts. And so it's clear that the more MH you have in the tuber, the less the sprouting. And it looks from it, I mean, this work will be continued and refined, but it looks like you need something above perhaps 10 mg per kilo to get some effective sprout control. Next slide, please. So I'll just talk about both of these, the fresh pack and the processing trials. They have much of the methodology is in common. So we net samples of the different varieties, and we bury them within a 1 ton box of bulk potatoes, and then store them in a positively ventilated store, each of 6 tons. So the key to this is that we don't actually see the individual varieties because they're buried within the surface. So we're unable to apply treatments according to need rather than their scheduled treatments. Storage was at 4.5 degrees C for the pre-pack, or 9 degrees C for the processing. So it's run at 4.5 degrees C just because we know that at 3 degrees C, sprouting would be quite restricted, and we might not easily be able to see the difference between the different sprout suppressants. Were we to do this again, we would certainly think to do it at a lower temperature. We unload the store every 3, 6 and 9 months, take samples out for various quality assessments that you'll see in a minute. Next slide, please. So there's also some in-store chemical treatments. There'll be a list following this, but it's just a reminder that we use hot fogging to apply the store treatments, in part because that's the recommendation, but also to avoid accidental or incidental ethylene contamination within the store. We've used, for these particular trials, so this is from 2019 to 2020, we used a 48-hour store closure period for Biox-M and for DMN. Next slide, please. So this is the fresh pack trial. There's 4 varieties: Edward, Piper, Melody and Nectar. They vary in dormancy. So Edward, as we saw a bit earlier, is non-dormant, and Nectar is quite a dormant variety. Here the We've also got MH residues at the start, and they're averaging about 10 mg per kilo. So we would say that's towards the lower end of what we think would provide really good sprout control. The treatments below are spearmint oil. They're all applied as per label. So spearmint and a total of 360. So that's a good dose. DMN, CIPC in that 2019-2020, CIPC was still allowed. So we used that as a control. And we've also used ethylene. So a ramped introduction up to 10 parts per million, and then continuous ethylene after that. Next slide, please. So I'm just showing the results for the 9-month storage. Before that, the sprouting was relatively limited, and it's not very easy to discern treatment effects. For the sake of making this webinar slightly shorter, I've combined the data sets. So what we're looking here at is the average value of sprouting of the combined Edward, Piper, Melody and Nectar data following 9-month storage at 4.5 degrees. And we can see a number of things from this particular graph. The first is that MH provides a very significant sprout control on its own. So it's it reduces sprouting by around 1/3. The second thing is that DMN is particularly effective, actually very effective. But spearmint oil and ethylene, spearmint oil particularly, and ethylene perhaps with MH, still have a role to play in, particularly with perhaps more long dormant varieties. And CIPC is quite good. Although the error bars don't allow much discrimination, it's actually clear, particularly when you look at the individual varieties, that maleic hydrazide improves the efficacy of each of those different treatments. It's not very clear on this graph, but that it is true. Next slide, please. So this slide's slightly more complicated, and I'll simplify it for the next slide. But this is showing sprouting after storage and shelf life. So I've just shown you the sprouting after storage, and that's the lower, I'm going to guess and say blue bar, I should have asked. And above that is an extensive red bar, I guess. And that red bar is, in essence, it's the sprouting that we see during shelf life. Shelf life in this case is 12 days at 12 degrees C. Again, it's the combined data. Next slide, please. So what I've done here is sort of, you might call it cheating, but I've simply subtracted the sprouting that we see after 9-month storage from the sprouting that we see following shelf life, and it just gives us a better view of the effectiveness of any of the treatments. It's very clear that maleic hydrazide is providing a good measure of sprout control during this shelf life period. So those bars are nearly all the same right the way through. We're not seeing any sprout control really by ethylene or spearmint oil. But we know that CIPC has a strong residual component, and that on its own will reduce sprouting. We also see something similar with DMN. So that will be quite interesting, I think, to see if that's replicated, because this DMN, this is a result round about 8 to 10 weeks after the last DMN application. So if that's true, that's quite a long persisting effect. So yes, I don't think there's much there. Next slide then, please. So this is a brief summary of that data. So it really highlights the importance of MH. So if you can use it, it looks it's a cheap, very cost-effective sprout suppressant. It's provided control up to 9 months storage. It's assisted in the suppression with other treatments. So there's either a synergistic or a combined effect. I've highlighted here that Biox-M and DMN are both effective sprout suppressants, particularly with Biox-M with MH. But I would just like to point out that ethylene with MH was also could provide an effective control for longer dormant varieties. MH in particular provides ongoing sprout control during shelf life. I did mention during the methodology part of the talk that all of these varieties have been put into a box. So they're mixed varieties of different dormancies, different other characteristics. So we really ought to be able to optimize treatment for variety and for storage duration and obtain much better results and use much less sprout suppressant, I think, particularly if we were to use a more normal fresh pack temperature. We also ought to think about optimizing treatment application. So this is quite a new development in a sense for us, that although some of these treatments have been around for a long time, the optimal application methods are still developing, if I can phrase it like that. And maleic hydrazide gives us a bit of backup in that, because it provides some backup. Next slide, please. So this is the corresponding trial for processing. So the number is 1043, and once again, the report is available on the AHDB potato hub site. There's 5 varieties there, 4 chippers and CRISPR, and the MH residues that were found for them. So this is much more mixed than in the previous trial. We've got values from 5.1 to 22.3. 22.3 is a very respectable, healthy amount of MH. 5.1 is a bit miserable, to be honest. So anything we saw there would be very valuable. Below that, at the bottom, there's a panel with the treatments, which all applied as per label, pretty nearly. So spearmint oil was the full total dose was applied as 60 ml applications. DMN, there was some capacity to add more DMN than was used in this particular processing trial. So we should bear that in mind. It's not a full dose. CIPC 24 grams. Ethylene, as before, ramped and then continuous 10 parts per million. I've included Smart Block here, but I've just realized that I haven't actually put up any of the results for it. So apologies for that. That's not because Smart Block is no good. On the contrary, it's an absolutely excellent sprout suppressant treatment. And one day somebody competent will show this trial and show how good Smart Block can be. Next slide, please. So this is sprouting after 9 months. And again, it's the combined data. So that's varieties that are more or less dormant. And all of that data has been just compiled and averaged. Once again, we can see the clear effect of maleic hydrazide, MH, in reducing sprouting. You can see that ethylene and spearmint on their own aren't particularly special, but in combination with MH, they're starting to look okay. starting and can have a role. And DMN on its own is an effective suppressant. Just to remind you that it didn't receive a full dose. And the other thing is that maleic hydrazide improves the efficacy of all of those other treatments when they're applied in combination. Next slide, please. So here, I said 4 of the varieties were French fry varieties, and I'm not showing the crisp data for the other variety, but this is just to show the effect of the various treatments on fry colour, and from that panel, they're all an AHDB fry colour score of 3, which corresponds to the USDA 0. And there's no effective treatment there. And that's actually applying, that's actually also for ethylene. So there's quite a lot of concern about the impact of ethylene on French fry colour and crisp colour, but here we're seeing no effect at all, and that's across 4 varieties. Next slide, please. Get a roundup of that main processing trial. So once again, it's highlighting the effect and the importance actually of MH. It's working up to 9 months of storage. It improves the efficacy in the presence of other sprout suppressants. What DMN was a very effective, the most effective sprout suppressant. Biox-M and MH provided the best combination of treatments currently available to GB, but that's not to discount the value of Biox-M on its own, or indeed ethylene and MH for possibly for longer dormant varieties. What I didn't show was another couple of points of real interest to the industry. So maleic hydrazide reduced the instance of internal sprouting, and that's a very clear effect, and you can see more of that in the 1043 report. The other one is that some of these trials were run using allowing the CO2 to build up to 1%. And in the absence of ethylene, if I remind you again that our stores are very good and don't allow leakage, but also we weren't inadvertently putting ethylene into the store by the method of application of the chemicals. So CO2 atmospheres of up to 1% in the absence of ethylene did not impact at all on fry colour. So that's quite an interesting observation. That's not to say that you shouldn't be what's the phrase, very lax about CO2 control. Obviously, it has a human health component to it, but it does mean that that we can rethink how we control CO2 within stores. Once again, all of these varieties, they were mixed in the trial, so we need to optimize treatments for the varieties and for storage durations, and I think we would find better results and cheaper solutions, using less chemical, for example. And again, is the treatment application, so store closure period, is that optimal? That's something else that needs to be looked at, I think. Next slide. I think that is actually the last slide. So thanks very much. And if you've got any questions, I'm sure they'll pop up on the chat sooner or later.
Yeah, thanks for that, Glyn. Some interesting results there from Sutton Bridge, but a few questions have come in, but I think we'll tackle them at the end. So, we make sure we have enough time for everyone. And Adrian's just popped on screen. So yeah, up next is Adrian, who'll be talking about weight loss and compression in long-term storage.
Thank you, Alex. Good afternoon, everybody. Yes, the talk today will focus on that particular area. But just as a reminder of the current state of play, and this ties in well with what Glyn's just been talking about. If I could have the next slide, please. This is where we're at with sprout suppression, which is not moved on really from where we've been for some time. 3 actives available in this season 2020-2021, and additionally a limited volume of DMN on an emergency approval, which has been in specific markets, has resulted in quite a low level of usage because of the restrictions that were put in, and that emergency approval expires in 10 days' time. So the big hope is that we will see some progress in terms of approvals for 21-22, but at the moment we don't have anything confirmed, and we have reporting dates extending into October for some of the applications that are currently in. So it's going to be right down to the wire again, unfortunately, but that's where we're at. Looking a little longer down the track, then potential for 3-deck and 2-own, which was also mentioned by Glyn, maybe next year. And then in the middle there, we've got limonene or orange oil, which will be marketed as Argos by UPL. And I think they're hopeful of getting something through on that during the course of the 21-22 season. Exactly when that will happen, again, we wait to see. So that's where we're at with the suppressants. Next slide, please. So I think this year we've been largely reliant on spearmint oil or ethylene, both with the foundation of maleic hydrazide. I just wanted to talk about mint oil again. The Biox-M label stipulates the importance of ventilation as part of the management needed for optimizing its performance. And if I have the next slide, please. One of the crucial things here is to prevent condensation events, and so that's why we've recommended for best practice to run fans without cooling for 24 hours prior to application to eliminate any residual moisture or any temperature gradients that might lead to condensation events, even hidden condensation events within piles, etc., within boxes. And we urge you to work with your contractor to set up the store correctly for the application, and work with fans to recirculate the product. And this is where we have suggested that you strike a balance between moving enough air and fog around the store, which is important for distribution, and to avoid any localized concentrated deposits of chemical on the top. But over ventilation is something else which has been brought to our attention more in feedback we're getting. It is an additional factor here. How long might we want to vent for after an application of a product like mint oil? Next slide, please. And it's not only mint oil. If we've got a DMN available, then I think the same arguments will apply to a large extent. The application does require an extended recirculation of air, especially in box stores, to try and get that evenness and distribution. But how long are we going to do that for? I'm interested to hear how you've been getting on this season and what your closure periods after fogging have been. So we're just going to do a quick quiz on that. If Christian can bring up the appropriate poll slide, please. If you could just fill in one of these. I think the bottom one should say no recirculation used, but you get the gist. We'll just give it a few seconds to see what we get. back.
Yeah, we got about a third voted so far, so I'll wait till we're a bit higher up before closing it.
Okay, so should we go with that then, Christian? Okay, so I can't actually read the on my slide. I can't see underneath the.
Okay, I can read out for you if you want.
Yes, please.
Have you got it? Yep. So we got 10%. We got 10% of people with 24 hours. 41% of people for 48 hours. That's the biggest. In second, we got 38% of people for 72 hours, and then it's 5% apiece for both 96 hours and no recirculation used.
Okay, thank you. If we go back to the slide, so that's excellent actually, because that's pretty much what I expected to see. So that's confirmed my my feelings on this. So the big question is, do we need fans on for all of this time? And if so, what are the consequences? And I've sort of slightly prejudged it by saying probably not at the bottom, but I'm going to have to explain myself in a few minutes, and I'll come back to that. Just before we do that, next slide, please. I just must mention the other sprouts-present option, ethylene. And just to say, why doesn't all this argument pertain to ethylene? Well, there's no real need for fans to distribute this product to the same extent, because it is an extremely small molecule. It has it's a gas with a molecular weight that is extremely close to that of air, so it does distribute very, very readily, and so we don't really need to think about ventilation to the same extent. So next slide, please. And so we're going to have these fans on after application of chemical. Does that have a downside? Well, we're seeing a trend in long-term potato storage as crops are being unloaded after this first season post-CIPC, where we're seeing some softening, we're seeing some weight loss, we're seeing some of this compression bruising that you can see on the screen there. We thought we'd just have a look at that and see whether there's any particular reason for that. Is it a seasonal factor? Maybe, but are we doing something to make this an issue? So next slide, please. What have we got when we're looking at weight loss? Well, weight loss comes from moisture exiting the tuber. It does that through the skin. On the left there, we have a sort of equilibrium across the skin of moisture going in and out of the tuber, or it can be lost through the soft tissue of the sprout at about 100 times the rate of the arrow on the left. So there's several factors at play here, and if we add air going past the potato at a rate, then it's going to take that moisture away even more rapidly. What is that going to mean? Well, more air doesn't necessarily make a difference, as that skin there is actually it's like a stopper in a bottle. It limits the rate at which it can be lost. So if we go to the next slide, we've got that constraining effect of the potato skin. Increasing the airflow rate doesn't significantly increase weight loss, but it is the continual depletion of the moisture around the crop that is key. And so bottom line is that weight loss is broadly proportional to venting time. And it doesn't really matter whether we've got a high volume or a low volume, it's the time that is crucial. At what time are those fans on? So the longer the fans are on, the more weight loss we will get, all other factors being equal. And if we go to the next slide, I did a quick calculation here as an example. I assumed that we would have normal ambient ventilation running for about 15% of the storage time, which is reasonably typical. That works out at about 650 hours. We added in 4 applications of chemical venting 72 hours each time. So that's 24 hours before application and 48 after. So that just came out as the top selection. It will be a little bit higher for those who are venting for a bit longer. And broadly, the venting time increased by about half. So we were getting up towards 44% higher. So if we just do a quick calculation on that, if our normal weight loss is probably 7% over a season, this additional ventilation could be increasing that to as much as 10%. And if we've got poor sprout control, then obviously we've got an even higher rate of loss through those soft tissue sprouts. So those are the sort of things that I wanted to just bring to everybody's attention and think about. Are we needing that? Are we needing that ventilation for that length of time? Is it actually doing any good? I think there's going to be a big difference between what we're doing in bulk stores compared with box stores, for example. And this all comes down to the old issue of positive ventilation. Where we've got positive ventilation, the use of air is going to be a lot more direct and specific than we're going to get with space ventilation or overhead throw type systems where the air is going around the potatoes. And if we go to the next slide, what can we do? Well, we can, in general, on weight loss, pay special attention to achieving really good skin set. That's been a bit of a challenge this year because it's the first year without Diquat. I think Simon will touch on that. Minimizing mechanical damage is always important because that's where we lose moisture. Optimize the store ventilation to ensure best delivery of air to the crops. So that's all of the old arguments about using things like plenums, managing any inconsistencies, particularly in these non-positive stores. So anything that's causing difficulty, back corners of stores, those sort of areas. And then also be careful in the use of inverters and speed control. Don't go down too low on those because we lose the pressure characteristics of the store and we don't get the distribution as good. It doesn't cost as much to run the fans, but it might not be as effective, and your fans will definitely be on for a longer time, so your weight loss will be affected. Use the ventilation very carefully when applying sprout control products to make sure that you're getting the material to the target. And also don't forget about those key issues of condensation control. And yes, we can represent the product to the target until all the chemical is delivered, but how good are we at knowing when that's actually been achieved? Because after that, we're probably not doing any benefit. Next slide, please. And I just thought it would be useful to just go back to 2017 when we were getting towards the latter end of the CIPC use and quite low doses, where we had to optimize our application more and more to make best use of CIPC that was available as the dose went down. And we brought in this concept of active recirculation, and I think that's really what we're coming back to. We can't just throw out all of those concepts which we had for active recirculation, and that came down to things like plenums within boxes, big box blocks, that type of thing. Those were all done for a reason, and I think those might be things that we have to revisit as part of the use of these chemicals going forward. So next slide, please. Just to finish, I'm just going to say a quick word on cost implications. So if some of you will have seen this slide before, some of the costs can get quite high when we're using multiple doses of new products. But if we add in that weight loss factor in the penultimate column there, then we could be adding to our costs further with this problem of high weight loss softening. And if we're running into problems like compression bruising, then the costs will be even higher due to rejection rates. So I think really just a lot of food there for thought for people to consider in the way that we use these new generation of chemicals going forward. And it's important that we take on board some of these points to try and fine-tune our management of potato storage going forward. And I'll leave it at that. Thank you.
Thanks, Adrian, for that. And now following on from this, we have Simon Alexander from SA Consulting, an agronomist who will be talking about what we wish we'd known a year ago.
Thank you. Right, basically, when Adrian first asked me if I would do this, it was sort of what did I think I'd learned over the last 12 months. So I'm going to touch on a number of things that I felt I've learned over the last 12 months. They're not necessarily backed up with science, more than observation, and anyone's obviously welcome to disagree. Next slide, please. I think not unlike everybody else, very concerned when we're going into this autumn that we hadn't got dicot, and how well we're going to kill some of these crops, especially some of the varieties like Agria Marquise on the more fertile sort of fen type soils. Historically, dicot had been quite an important part of that program. But I was absolutely astounded this year with the way that Goes Iron Spotlight, excuse me, both behaved in the early season. This is a photograph of a crop of Agria on some sort of blackish, heavy black soil. The Goes Iron was applied, as you can see, at 6:30 on the 4th of August. And the top photo on the left was taken, sorry, yeah, I've got them the wrong way around. So the top photo on the left was taken at 20 past 12 on the 5th, and you could see the start seeing a change. Well, that day, the 5th, was a nice, bright, sunny, warm day, and grower actually called me back to the field later that evening, and I was in the area, and you could see a massive difference. The difference in change you actually saw was not that dissimilar to what you would have seen with dicot. And I think generally most people would probably say that desiccation this year has probably been better and generally more straightforward than they were expecting. But all I will say is that it just worries me. It's going to lull us into a false sense of security. We're getting to a more normal season, and next year it may not be quite so simple. Yeah, my take home from desiccation this year actually is it was a lot easier than I was expecting, but I'm not expecting that to be the case going forward. Next slide, please. There's been a lot of talk about MH already, and the work that Glyn has shown. Well, what I'm showing is, again, is observations in store. This is a photograph taken of 2 Fontaine samples in the same store. Photograph was taken on the 3rd of April. The store is, or was, treated with ethylene, ramped up from the 16th of October. The machine was turned on, ramped up to 10 parts per million, and basically the sample on the left received no MH, and that was confirmed with a residue test on the 17th of November, showing it less than 0.2 milligrams per kilo. We started to see eye development on that crop in mid-January. It is not common source, I accept that, so yes, fair enough, anyone can argue it, but the sample on the right was MH treated, residue levels at 17 milligrams per kilo, tested exactly the same time, and you can see, if you look very closely on 1 or 2 of those on the right, we're starting to see a bit of eye movement. So personally, I would quite happily back up exactly what Glyn was talking about, that for me, MH has had quite a significant effect on sprout control in ethylene treated stores. As I said, at the end of the day, you can see the ones on the left have started to move, but they never got to the point of being unmanageable. Next slide, please. The biggest concern I've had this year with MH, sorry, is not only we sort of seeing variabilities across stocks, is the variability within a stock. And this is a sample of Taurus, same store, slightly deader corner, the box on the right. So the box on the left, you can argue mint oil hit it better and did a better job, control good. If you look at the box on the right, you can see some sprouts there. They are nowhere near as bad as they look, just to make that very clear, and they are only generally in the top few inches. But digging out of those, you can see from the photograph at the bottom, and my foot is in there purely for scale, they are by far the smaller fraction of that sample where we have seen more sprouting. Now, I can only put that down to the fact that they broke dormancy sooner and got away quicker. I didn't do it on this stock, but I did residue test a marquee sample and took potatoes, sort of a larger fraction out of the same boxes as I took some of the smaller fraction, sent those away. And on the small stuff, and that would have been 45 to 50 mil, it was graded into store on a 45, so it's 45 to 50 mil. There was 16 parts per million, and on the what would have been the 80 mil plus, that was up to 33. So you had got double the concentration in the large than you had in the small. And that has shown itself more this year, and I suspect probably because we're using mint oil, so it's hit it and no residual activity. So to me, my concern or my question is, how can we reduce that? How can we minimize that? But I'm not sure that anyone's necessarily got the answer at this stage. Next slide, please. Adrian touched on ethylene and its ability to move. This is a sample of Taurus crisps, and basically they were in a store that was built 25 years ago, so not by any means what we would class as an old store, in good condition. And the store was divided in two, dividing wall, which we knew potentially you occasionally get a little bit of CIPC leak if you gassed one side and not the other, but nothing horrendous. It wasn't the case that you wouldn't stand in the store when gassing. And to be honest, never entered our heads. One side was a processing crop and the other side was the Taurus for crisping. The machine was turned on, I can't remember exactly what date, in November. I haven't got a photograph of the stuff of the Taurus in November because I couldn't find a good representative photo. But we noticed as we were coming up to Christmas that the Taurus quality was deteriorating. And again, the ethylene was ramped up and run up to 10 parts per million. Testing of the side where the Taurus was, I think from the top of my head, we got to 3 parts per million. So we were definitely getting leakage of Taurus across. Now, both stores were positively ventilated, so you can't really say that you were building up big pressures between one side and another. But we were seeing quite considerable leakage across, and we put that down to the problem. We tried actually pressurizing the non-ethylene treated store to see whether we could do it. Yes, we reduced the level of ethylene, but not consistently low enough to start seeing some improvement. So just after Christmas, we turned the ethylene machine off and basically warmed the Taurus up, made sure we got plenty of fresh air through them, and you can see from the photograph in May that we have definitely managed to turn them around. Now, it's certainly not something I'd want to try and do on a regular basis or take for guarantee to do, but on this instance, we've managed to turn those around, thankfully. But it does just emphasize that ethylene, well, it's by nature of the fact that you don't need fans to move it around, is a very mobile product, and be very careful to ensure that you do not put yourself in a position where something that is sensitive to ethylene is in the store next door to where you're using ethylene, because it will move and can catch you out. Well, it was my first year of using it. It was not something I'd ever thought of. Next slide, please. Right, my comments now are purely and simply related to chip shop chips, not anything else. It's purely chip shop market. I was concerned at the start of the storage season that we had not seen a massive amount of good data to convince me that it was safe for me to use ethylene on chip shop material where I was looking for top end, high quality chip shop chips. And at the end of the day, assuming your dry matter size is right, fry quality is absolute king. So what I did was a grower I deal with in the Peterborough area. We took samples from his store and we fried them on the 16th of October. I took them back to Norfolk, put them in a store that had the ethylene machine turned on for 1 day before they went in. And were then left there. We fried them periodically, and to be honest, there's not a lot of change in what we've seen right the way through the season to what we've seen now. And basically, they were stored at 7.5 degrees. The flushing in that store was to achieve a maximum CO2 level of 2.5 to 3,000 ppm, and that was based on manual purging, timed purging based on the CO2 sensor on the ethylene machine. I had not got another store at 7.5 degrees where we got mint oil, so I was just comparing them with basically being happy that they were stuff that all stocks of these crops here have all gone into top end chip shop. So I'm happy that as a product they were frying well, and at 7.5 degrees I've got no issue with that as a temperature for any of these varieties. But the one thing it does show quite nicely is the difference in the way that varieties react. One thing I should just say is that the fry sampling on these is done in a manner of, there was one chip per potato, and basically they were fried at 190 degrees, and they were fried until they were cooked, because at the end of the day I don't want to go in a chip shop and have a half-cooked chip, so they were fried until they were cooked. So they were as close as possible replicating the customers that these were going to. That's why I'm emphasizing this is the results from a chip for chip shop use and not for anything else. But it's interesting that you're looking at the interim data for AHDB, and it shows Lady Anna reacting quite nicely. Now, again, I don't know, I haven't looked closely to see how they were fry sampled, but for me, fried in that manner, Lady Anna has actually performed worse. You can see these two. I'll then flick to the next two. If I can have the next slide, please. Because to put it into context, that is a marquee sample, not anything related to these. That was basically being sold at last on the 12th into chip shop. So even the marquees there, you can see, is still showing a lot more colour. And I accept that photographs don't always show brilliantly on colour, but I asked those that were in there whether any of the samples that I'd brought in there that were ethylene treated would hit the top end market today, to which the answer was no. So hence, I am still nervous about using ethylene for top end chip shop. Can I have the final slide, please? Right, just in summary, yes, the PPOs have worked well this year, but don't expect them to always do that. So we're slightly more prepared for a slower burn-off season this coming season than we had last year. One thing I didn't touch on is historically where I've had a crop that's with some green on it, where we've been in with a flail, I've tended to put a litre or a litre and a half of dicot on to sort of soften the blow of the flail and get rid of some of that canopy. I did some with PPO and some without, on the basis of the way it worked that fast early on, and we saw no difference in Q-seed samples at any point. So at the moment, I'm quite happy that flailing into a direct green crop this last year, we did not see any vascular discoloration, but that's again based on this last year. MH has worked well. I'm not sure that I've seen a great practical benefit in efficacy of sprout management where the residue levels have been above mid-teens, and I've put it mid-teens, sort of 12, 14, 15, 16. I mean, I've got the sample, the photograph I showed of that Taurus with the sprouting the small stuff, the residue levels on those fields in that store were between 30 and 50 parts per million. Well, I don't think they held anywhere else any better than where I had Taurus at 18 to 19. So this year, it seems that there's been a cut-off now. Whether that's something that we should expect and not get excited at the high levels, I don't know. I will watch with interest. My concern, as I pointed out, is the variability of MH within the sample. If it's within a stock, that's fine. You can manage that. That's not a problem. But it's how you manage it when you've got a range within the sample. And yeah, I don't know what can be done to get more into the smaller tubers. You'd have to say this last season, the MH application was probably as good as it's going to get. So if we're seeing it this year, what we're going to see in a year where it's more challenging. To me, mint oil has worked well where timing has been right this year. Yeah, there's been one or two issues, but nothing insurmountable, nothing that's caused for me that has caused me problems with customer. I put a question mark after increased weight loss over CIPC. I still have my doubts whether it is all down to Mintor this year. I think some of it is just conditions in climate, ventilation, purely on the basis of we had a hell of a lot of crop that went into store very wet this year. We got it dry, we've held it. So I suspect we've used more drier air than we'd anticipated, or certainly more volumes of better air. Hence the reason we're not seeing the amount of rots coming out of store that I certainly in December would have expected to see. Plant ethylene applications to assure no leakage to non-ethylene stores. Again, it's a product which it's its benefit, but it's cursed that it is very good at moving through any kind of gap. So just be careful if you've got stores where you're going to have to use some ethylene, and stores where you're not, make sure they are not adjoining. I don't even know that I'd want to try and rely on thinking that they were airtight. From my point of view, ethylene has worked well this year. Even better, we're backed up with MH, but yeah, I've had no problems where I've used it with sprout control. You're always going to see a little bit of sprouting, but certainly for me, it's done a good enough job for me. But I will also state that I will definitely not be recommending the use of ethylene on chip shop crop this season, not without a lot more information to allow me to ensure that I don't have the problems that I've seen with the samples that I've seen this year. Thank you.
Thanks for that, Simon. Some good observations. We'll head over to our Q&A just now, but so if we get everyone up on screen. But then the first thing I'd like to do, Christian, is if you could bring up my question at the start, the earlier poll. So far so good without CIPC. So we've got 25 strongly agree, 51 agree more than disagree, 18 disagree more than agree, and 5% strongly disagree. So I mean, Adrian, I guess we'll start with you. What are your thoughts on this? I'm pleased that more agree more than disagree, 51%. That's positive.
Yeah, absolutely. I think it's good that people are seeing it in a positive light, and I think it's good that we've got 25% who strongly agree, and basically 3/4 who are in the top two categories. So that's really encouraging, and I know we haven't got the full toolbox available for everybody at the moment that we would hope to have, but it is good that we have been able to do a really good job with maleic hydrazide as the foundation treatment and the other products on top of that. So yeah, I'm encouraged.
Good. And Simon, do you have any thoughts on this? What are your thoughts?
I know that there have been some problems out and about there this year, but I think as I sit here today, if you'd have told me this time last year that I would be where I am today, I would have taken your hand off. I can't. I'm in the strongly agree category.
Brilliant. Good. And finally from you, Glyn.
With the other two panelists. So this time last year, there was a lot of nervousness about what was going to happen in the absence of CIPC when there was spearmint and ethylene available, and yet we're getting 3/4 of the poll are saying it's much more positive than that. So yes, good result, I would say.
Good, brilliant. And then so just moving on from that, if everyone's finished their points on that, there was another good question from Andrew Wilson, basically sort of saying without maleic hydrazide, potato storage is in a tricky situation, or what are your thoughts on that one?
I would say it has been the rock on which we based our storage this year. I mean, I think it's the important thing is the residual control that it gives, and Glyn illustrated that in some of his data, that that we've been so used to having a residual effect from CIPC that still active after we've unloaded, etc., etc. And that's really important element that maleic hydrazide brings, because some of these other products are much more volatile, and their contact action and short-term action, and as soon as you take the product away, then the control can be lost.
Yeah. And Simon?
My concern is that we've had a very good year of application of MH this year, and we've still seen some very variable results. It's an old product, but we're still learning how to apply it, and how to get the best out of it. And if we have a more catchy season next year and we don't get it on as well, or God forbid we don't get it on some crops, then that could be a very different story. I think Andrew's possibly being a tad negative, but it certainly has made a difference.
Yeah. No, I think it's fair point. If we do lose MH, we'll have to see what happens with that. But Glyn, I know we're looking at doing some more maleic hydrazide work this year, aren't we? At looking at humidity and time of day. So hopefully at the end of this year, we'll have some more concrete results on the best application techniques.
Yes, so that's true. So it's Adrian Britton's really running some of the trials, but it's clear that application of MH is obviously critical. And there are still things that we don't know well enough. So timing is starting to look better, but the state of the crop is a difficult one. And for example, I think one of the things Adrian is looking at is how long the MH remains available for absorption by the leaf surface. So if there's a lot of high humidity, so later in the evening, does that allow better absorption of MH or take up of MH than if it's first thing in the morning? So late evening or early morning. I think those are some of the kinds of trials that Adrian is running.
Yeah. So I think we'll start with some questions that came in when you were speaking, Glyn. Why did the processing varieties show such diverse MH levels? Is this due to uptake at application, or is it to the speed of degradation within the variety of what other attribute?
A very good question, and I don't think we know the answer to it. So we haven't got many years' results of this of the MH residue levels of these particular varieties. So whether it was a one-off and that the Royal had particularly low MH, we're not sure. So there's a couple of thoughts, really. Firstly, that it's something to do with determinacy. And as Royal is a very indeterminate variety compared to Innovator, for example, and which had a very high level of MH. So is that something to do with it, determinacy of the crop, and therefore how it, the state of the canopy when the MH is applied? So Adrian and Paul Coleman, I think, have got some ideas there, and they're being run at spot trials this year. I think the other thing we could simply do is actually just sample some indeterminate stocks, such as Royal, for example, following harvest this year, just to see whether it's always much lower than a determinate variety. I mean, it may just be, it may just be a one-off result, or it may be something to do with determinacy.
Yeah, brilliant. And the next one, which you might not be able to answer at this moment, and if not, we'll get back. But for the rates you used, Glyn, what's the cost of each sprout suppressant treatment?
Well, if we could just go back, so Adrian's actually shown that in in his slide, I don't have the results to hand. MH, I know, is about £2 a tonne. Ethylene, something like 350 a tonne, but I can't actually remember for Biox or for DMN.
Adrian,
the Biox is about £5.5 an application, and I can't remember how many applications we made to that trial. I think probably 3 or 4. Yeah.
Oh, it will be getting on for 6.
Oh, because we're a lower dose.
At 60, yes.
Oh, well, okay.
Yeah. So if 550 for 9, was the 550 for 90?
Not sure. I think it was probably for 60, but that's a commercial rate, so I don't think you would be using 6 in commercial.
Absolutely. So I think I did make the point that what we were trying to do was to compare the efficacy of sprout suppressants, having to use the label rate, partly because we're unable to, and secondly, if we do it any other way, we'll have people saying, well, that's not fair. You know, we've got poor results, but we've only used a quarter of the total available dose. So I think we are where we are with that. We recognise that we probably over-treated, but I think I made the point that we ought to be able to optimise the treatment much more carefully. For example, if you can look at the stock and apply when it's required rather than on a scheduled basis.
I think we acknowledge that there is quite a lot of work to do on different rates and different. We're just at the start of this learning curve, really, with these products. There's quite a lot of work to do on use of different rates and different combinations. We've certainly got quite a long way down the road in the first 2 or 3 years, but there's still work to do. I know people are using, for example, ethylene at much lower rates than the standard 10 ppm. There's quite a lot of use of 4 now, so you know, there's a lot more information to be gathered on that.
Yeah.
So question for you now, Adrian. Is there more dehydration, or are we seeing it more because stores are being monitored more closely than in the past?
I think it's definitely an effect this season that we've picked out. I'm not totally convinced that it's because people are being more vigilant. I think I've certainly seen more compression bruising this year than I've seen for quite some time. So there is a factor, but Simon's also touched on the fact that there were some issues at the start of the season, which may well be a seasonal factor. Some areas of the country did have very high rainfall, had a lot of drying to do, and that can affect weight loss. So it could be a combination of factors, I suspect, but certainly adding significant ventilation hours isn't doing any favors in terms of weight loss, but obviously it needs to be done to get the chemical around the store. It's just a question of knowing when to balance that. And I was interested to see some comments coming in on the questions from Chart Hoffman over in the Netherlands, who was saying that their approach with recirculation of certainly on the Biox product is a little bit more conservative in the use of ventilation.
Okay, we'll rattle through these now because there are quite a lot, but if we don't get to answer your question, we will get back to you after the webinar via email. But Adrian, are there any rehydration techniques that are effective?
I guess what's being implied there are things like humidification, which humidification slows down the process of moisture loss, but I don't think it contributes in any significant way to rehydrating potatoes. So I don't think the answer to that is no, really.
Okay, what do you think of CO2 extractors? Are they beneficial?
CO2 extractors for taking out stratified CO2 in stores, I guess that's what's being referred to here. So there's some systems around which basically flush stores, and they tend to work at low level in the store because CO2 is heavier than air, and pull that CO2 out. There are also some heat exchange systems which can be used for that purpose as well, that are quite useful. But it was interesting when we went to Netherlands and Germany. Can't remember when it was. I think it was April 2019 actually, and we saw quite a lot of those types of CO2 extraction systems being shut down when they were using these more volatile sprout suppressants, but mainly because on automated settings they were over ventilating the store and taking too much air out. Now all that comes down to me, it's just getting the control right, as far as I can see. I mean, I think it's still important that we do have some control of CO2, but what we don't want is uncontrolled ventilation of the space. So it needs to be specific and being done for a purpose, not just being put on a time switch and just coming on irrespective of what the demand is.
Yeah. Now, a couple for Simon. Does, on those smaller tubers you showed, does the size of tuber relate to maleic hydrazide levels?
So I hadn't residue tested those, Taurus, but where I'd done some marquees, there definitely was a 100% difference in the concentration of MH between 16 to 33. Yeah, so from what I've seen, it does seem that the smaller tubers do seem to have less in them. But the question is, how can we improve that? And I don't know.
Yep. And what would you consider using if no ethylene on chippers?
At the moment, there's only one other option. It's mint oil. And that doesn't seem to have had a detrimental effect. So at the moment, I will be using mint oil.
That's over and above maleic hydrazide, Simon, I take it.
Yeah, that'll be with MH, yes.
Yeah.
Yeah.
I am aware of some people who've gone through the whole season just on MH, but their season was probably not until now.
Yeah, and at the end of the day, they'll get treated if needed, if the MH is such. But then, why is it some years we'll see MH hold stuff until April, May, and then yep, we've got the levels we've got this year, and not much held past about February.
And then I think this one's for Glyn. How long after last treatment with anti-sprouting have you evaluated the shelf life?
So the last spearmint oil was applied, so ethylene was nearly continuous. Last spearmint oil before shelf life was about, I think, 6 weeks, and the last DMN was, I think, about 8 to 10 weeks. So that's actually a significant length of time. So it's either, I'm not saying that DMN has got a residual activity. It's an interesting observation, and we'll see if it's replicated this year. But DMN does have, maybe it sends them to sleep longer than we think. In that particular trial, I would say we did over-treat with DMN, because we were using label recommendation rates.
Yeah. Okay, so I think that wraps up our Q&A for now. Just because of timings, we will get back to you via email on the questions we haven't answered. But I thought just before you go, please remember the Storage Hub is on the AHDB website to see all the additional resources and latest research, as well as staying up to date with the Storage Bulletin, which you can sort of subscribe to on the Keeping in Touch page. And if you have any questions regarding your storage, please contact the experts at Sutton Bridge, and their details are on the Storage Hub on the AHDB website. And I've also attached the Store Manager's Guide in the handout section near the questions box. So if you wish, please download this for your viewing. Another point before we close, we're running 2 more storage webinars. So next slide. We're running 2 more webinars in the coming months regarding potato storage, and they're as follows. So on the 1st of June, we have efficient storage, which is focusing on particularly energy efficiency and managing costs. And on the 15th of June, we have maleic hydrazide, a foundation for storage, so focusing everything regarding MH. And to sign up to those or learn more about them, please go on the AHDB events page on the website. And if you have any questions regarding the webinar today or any other general inquiries, please contact me, Alex Wade, at ahdb.org.uk. And if you don't have time to jot those down, they are on the AHDB website in the potato section on the contact us. So that just leaves me to say thank you to all our speakers today, Glyn, Adrian and Simon. Thank you for your efforts, and thank you to all who watched, and I hope you gained some value. So thank you, have a good rest of the day, and I'll see you in the next one.